I'm Julia Semprich and I'm a research fellow in astrobiology U at the Open University. I study rocks in the crust and in the mantle of Earth and other planets such as Venus. And the very interesting part about this is that a lot of these rocks are tens and hundreds of kilometers at depth, so we cannot actually see what's happening. And that's why I'm using modeling in many cases to understand how they behave. And we expect that, for example, temperatures and pressures increase a lot and can get up to melting temperatures. And these are temperatures about 800 to 1,000 degrees. So 4 to 5 times more than what you would need to bake a pizza. And once your rock reaches a certain temperature that is okay for melting, you will have a molten rock that rises up, and that's what we see as volcanoes. And one of these, or many of these volcanoes are, for example, in Iceland. This is a rock from Iceland. That's a basalt that comes up from the interior of the Earth. And we think that the Venus surface looks very much like that. So Venus is very interesting because it is very similar in size to Earth. It is a bit closer to the sun, but it looks completely different than Earth. So we have water, we have oceans, we have life on Earth. Venus doesn't have any of this. However, very early in its history, it very likely had water. It may even have had oceans, and maybe it had also life. So it is very interesting to understand what happened in the history of Venus that is so different than what happened to Earth. And it is also very interesting to see what Earth could maybe look like in the very distant future, because Venus now has a CO2-rich atmosphere. Eventually, Earth may look like Venus, and studying what happens on Venus is interesting for our future as well. In the 70s and 80s, the Soviet Union sent a series of missions to Venus. First it was flybys, then it was a probe just descending into the atmosphere, and eventually it landed. And what many people don't know is that the Venus was actually the first planet another mission landed on, even before Mars. And the problem is, though, that everything on Venus doesn't survive for very long. So you have to imagine you have 470 degrees on the surface. It's really hot, it's CO2, and there's a bit of acidity in the air, so it's corrosive. And everything that lands there cannot really survive for very long. And some of these landers brought back pictures. They gave us a very limited amount of the composition of where they landed, so we know the composition of the rocks, but they didn't survive for longer than, I think the longest was about 100 minutes, and then there was no transmission anymore. So after these landers, unfortunately, we didn't have any other mission that landed on the surface of Venus, but we did have a few orbiters that can study the surface consistency of Venus. However, it's very difficult because there's a very thick atmosphere, so we need to use radar instruments to actually look through this thick atmosphere. And a couple of missions have studied the surface of Venus and the atmosphere as well. One of it is NASA's Magellan mission, one is Venus Express, run by ESA, and one is the Japanese mission Akatsuki, which is still running and studying atmosphere interactions and storm eyes and things like that on Venus. There are 3 very major missions that have been selected. 2 NASA missions. One is called Da Vinci, and it is very exciting because it will have a descending probe. So it will not only have an orbiter that will stay in orbit on Venus and look at the surface, but it will also send a probe down, measure the atmospheric composition, and then hopefully, if it survives, bring images from one of the Venus highlands for which we don't have any data at all. Then we have Veritas, which is also another NASA mission. This is mostly an orbiter. It uses a series of radar instruments to get better data from the surface, such as gravity and some elevation data. Unfortunately, all of these take a long time to be prepared, so they will likely only fly in the late 2020s, early 2030s. Then there is one mission that may fly earlier, which is currently called the Venus Life Finder, and that is a privately funded mission which will have only a very small instrument load that will try to figure out if there is any life in the clouds. It will survive maybe for an hour and may fly as early as in 2 years. I think that for the next 5 years there's not going to be a lot new data for Venus, because all of the new missions that have been selected take a lot of time until all the instruments are developed and everything is going to fly. So for the next 5 years, I'm pretty sure we have to rely on the existing data we have for Venus, which is very limited, unfortunately, and probably experiments and modeling efforts as we already do. In the next 10 years, we could probably already look forward to some of the new data sets that we get from the new missions, if they are on time. If not, then this will likely be maybe in 15 years, who knows. And then in 50 years, I'm hoping that maybe we will get another lander, because the technology should be better. We should be able to create some containers that actually have a lander running for a bit longer than just about an hour or 2 hours, and hopefully get better data from the rocks, better images from the surface of Venus. Maybe even a rover, if it can drive there. That would be nice. I'm actually really excited that Venus has now been put back into the window of interest for planetary science, that we get missions, because there was a scarcity of missions in the last 20 years. We believe that Venus is volcanically active, so just looking or getting actual real good data for that would be really exciting. I think that all planetary science, all space exploration should follow the rule that planets should be left in a pristine stage, and that would also then eventually, if technology is good enough to go to Venus, that should also be valid for Venus. So I think we should be very careful and have ethical or space ethics present to make sure that planets are not exploited, mined, or that we actually do the same thing to another planet as we do in some areas on Earth.